And getting ready for Harry Robertsson, Technical Director from Stena Rederi. And if everybody's looking out the window that direction, you may see a big white ship that is a bit, I guess, hope under your control, Harry?
Well, actually, it's under Stena Line's control.
Okay.
Yeah.
But you're just checking on it so from time to time. That's
from time
good.
to time.
Just curious, how long is that ship?
What did you say? It 74. Six.
Yes. Okay. Exactly.
It's not that easy.
No, it's not at all. Marcus, what kind of expectations do you have here on Harry's presentation?
Digitalization in ship operations. Ship operations are very complex in my humble view, and together with that, the 90% of world transportation goes on water. It's the most energy efficient way of transport things, and it's also the shipping part is an important part of the national infrastructure for transports, not only air transports, road and railways and so on. So just imagine 90% of the transportation is wet. So that shows the importance of this, and it will be very interesting to hear how do you digitalize this, and how do you use new technology to improve shipping.
I will see whether I can give you a view on that, or if you need to come back next year. Digitalization of ship operation. Well, let's see now. Who am I to tell you about this? Well, I'm actually born in Stockholm. I'm working in Gothenburg for Stena. My career details is that I was a naval architect from Stockholm in 1982, a long time ago. And then I worked for the Swedish authorities, maritime authorities. And I have also been on a shipyard, GVA in Gothenburg. And then I was working for two consultancy companies, Pelmatic, maybe you know that, you who are from Karlskrona. The head office was here in Karlskrona. And since '96, I've been working for Stena, and I got my present position already in '99. Stena AB, about 15,000 employees. We are operating about 200 vessels, and we also have some other parts. And this is another way to present the Stena Group. We have a shipping maritime part that is to your left. We have the shipping part, which is headed by Carl-Johan Hagman. There is Stena Roro, Stena Bulk, which is not bulkers, it's tank ships. Concordia Maritime, that is the only part of Stena that is on the stock market, but 48%. Stena Teknik, which I represent, and then we have Northern Marine, who man all our ships. The head office is in Glasgow. Stena Line, which is the ferries out here, plus some 38 more ferries around Europe. And then we have the drilling part with its head office in Aberdeen. And then we have the other parts as well. We have the Stena Oil, where is that? Over here. That is bunkering our vessels. This is my organization. We are taking care of the new buildings. We are ordering ships, but we are also involved in research and development. And our task is to provide marine technology expertise to the Stena sphere to improve the competitiveness of our companies. This is what we have done over the years. In the mid-90s, we developed the high-speed vessels that was operating here in Europe. These are, or if they should still exist, be the biggest aluminium construction in the world. Each of these vessels had 100,000 horsepower. I have personally traveled 51.2 knots over the Irish Sea, and then the ship was half loaded with trucks. This is the Charisma, which is the one that is still at quayside in Gothenburg. Then we have built a number of ro-ros and rope axes, tankers, and some drilling units as well. We have actually the world's biggest rope axe operating between Hook van Holland and Harwich. And the vessel that was mentioned before, Stena Germanica, is actually number 3 and number 4 in the world, size-wise. This is our current new building program. We have the Stena Midmax, a semi-submersible under construction in Korea. We are involved in a new building project of a hospital ship together with Mercy ships. They are conducting surgeries along the coast of Africa. We have a program of 13 tankers in China. We have taken delivery of 8, and just recently we ordered 4+4 rope axes also in China. Over to the topic of today then. What is digitalization? It's a buzzword, isn't it? People are, talking about drones as a sign of digitalization. I will try to give you my view, but first, a movie. This is what you, Fredrik, was talking about, that everything is connected. The tram is, giving signals that it's about to leave, and then people around could see that this is moving. Or when it leaves, a lot of information can be transferred. But all of these people around, they are, as Fredrik said, connected together, in all, submitting information, and this is all connected. This was all shown by Fredrik, but I'd like to just give you a picture of what's in the shore-based society today. This is a building that you talked about that gives signals to, are submitting signals, information that could be used. It's open. And also, if you can use this information for business opportunities, these parking lots are empty, so they can actually transfer information to possible customers and so on. Giving you can always you have to be connected to be competitive in the future. But this is just to show where we are on shore today. And then we can show movie number 2. This is a picture of a registration of all ships that is controlled by ship owners. This animation is from last year. It's actually made by a Gothenburg company. And this information is, you can get the speed of these vessels, where it's coming from and where it's heading, and also what kind of draft the vessel have. But I would say that we in shipping are what you said, that where we were in the late 90s on shore. Because it's expensive to put in sensors and it's expensive to send the information because we have to use satellites most of the time. So here is a business opportunity for everyone that wants to digitalize the shipping world. What we see is that maintenance, we could improve maintenance quite heavily by introducing sensors, more sensors than we have on board. In the late 90s, beginning of 2000, we actually reduced the automation of our ships because we were too advanced. We had to employ extra people on board our ship to make the automation system work. And that was not the purpose of that. The investment was to actually reduce cost. But what we have to do to understand is all the information that these sensors are giving us. We don't want to make the maintenance actions too early because then it's no use. And we don't want to have breakdowns because we don't understand the signals. Autonomous ships, I think that you, Robert, have talked about that. We have all kinds of systems on board, but they are not connected together. And the reason why we are talking about autonomous ships, that is to improve safety, is not to get rid of people on board. We would enhance safety on board our ships. And we want all these systems to be able to talk to each other, to give the crew on board a better decision support. We also think that these systems we need to add equipment and sensors to improve that as well, to see canoes and swimmers and small boats. We also like new ships to be more efficient than today. We think that if we add sensors to the hull, we could reduce the steel weight of the ship. The steel weight is the main part of the hull weight, the displacement. And we have said that if we can reduce the light weight of a vessel to half, then we reduce the displacement with 25%. And that gives us 10% less fuel consumption. We also work to reduce the number of systems installed on board. How can we do that? Well, for instance, do we really need to have a ballast system on board the ship? By introducing sensors, reading the information of floating position and so on the ships, it might be that we can operate the ship without the ballast system. We reduce the weight and also the cost of maintenance. All equipment used in port should remain ashore. Why should we carry heavy equipment back and forth over the sea? Expensive equipment, well, this goes for the new building cost. We should install propulsion late because it's expensive, reducing the cost for the construction of the vessel. This, Fredrik, I think could be interesting. Reduce the cabling. I don't know how it works with steel, but we think that it's a little bit too much cabling on board the ship. We even raise the wheelhouse, the deck of the wheelhouse, 1.5 meters to be able to pull cables underneath. If we could reduce that, we can get the capex down on the vessels. The same goes by piping. And to have these timetables more optimized by using the information created from our operation, then we could increase the time to sea and also reduce the speed and save money. Energy efficiency, well, I should say that we have made a video where one of our captain explains why we have put about 5 years of development work into this system.
This is how we used to get from A to B. Today, our captains need to take a few more things into consideration. Things like reducing environmental impact, being more fuel efficient, and optimizing the overall journey. But thankfully, there are tools available to provide a helping hand.
RTM is real-time monitoring of various sensors aboard.
Condition monitoring sensors throughout the ship measure internal factors such as fuel consumption, vibrations, and engine power. But equally important are external factors like wind, currents, waves, and depth. These all affect the fuel consumption as well as engine power.
Digitalization means that we can making graphs, and you can see historical values and also direct values. One more advantage is the increase of the knowledge base aboard. Decisions and discussions is factor-based, not views.
All collected data is saved and put into the fuel measuring system. This allows the engineers on shore to analyze and compare years' worth of data. This is to measure progress and see results of decisions taken.
In the future, one improvement should be to be able to share data with other ships on the same route. Today, we are collecting data from Weather Forecast Institute. If this is wrong, then the analysis of the trip is also wrong. By share data from the ship which leave one area which we are coming into, then we can reevaluate the analysis of the trip.
The digitalization of our condition monitoring, together with the experience and knowledge of our crew, can make a real difference in the way we navigate our fleet towards a more sustainable future.
Okay. Actually, when we did this, when we took decision to develop this system, there wasn't any system in the world that we could actually buy off the shelf. So we had to develop it ourselves. Now we have installed it on almost all our ships. And what it does is that the real-time monitoring gives the crew the possibility to take action in the wheelhouse to reduce the fuel consumption right away. We have an example which is quite good. Our Stena Nautica was, they were looking at their gauges when they were traveling from Grenå to Varberg, back and forth. And all of a sudden they saw that in the middle of the sea, the fuel consumption was higher than for the rest of the trip. And then they looked at the sea chart, and then they saw this lesser depth, water depth. And nowadays they go around this to save fuel. But it's not only, and then this display could be shown in the way they want to have it on the bridge. We also take in statistical data and from the ships, and this is the consumption for a year for Stena Hollandica. And as you see, there is a lot of dots. This is actually every 10 minutes for a year. yeah, for a year, almost. And to be able to take any conclusions, draw any conclusions from this, we had to put a mathematician to analyze this, and then taking away, treating this by statistics, he could reduce the span to the black part here, and then we could from that take an average, which is the green, and then we take it, change it out with the depth and the wind and waves and so on. So we get the blue line, and the blue line could be compared with the model test data. So we're not that far off in our operation. Then this is analyzed, and then we take actions to sort of keep that as narrow as possible. So this is part of what we do within digitalization. Then we have a commercial side that is also using digitalization, but this is technical operation. To conclude, what can be measured can be controlled, but the collected information needs to be structured, as I showed in the graph, properly, and we need to understand what we see from the data before we take any actions and draw conclusions. And this is actually the future, the next generation Stena ship, not the one that we ordered in China, but 10 years from now we will have a battery-driven vessel with a nice decision support tool on board. You can see here there is no bridge wings. Okay, thank you. Thank you.
A small gift from Karlskrona, a lot of good things in there. Save them for Saturday. I just had a quick reflection. I understand the cabling thing that could be replaced, but the piping, it feels like it's a bit more physical things.
Yeah, right.
You cannot really do that Bluetooth-wise.
I'm not sure that we are making the arrangement as we do when we are building houses. Put the water part, so bathrooms and kitchens and so on, close to each other. I think we are putting them all over the place. So by smart arrangements, we could reduce the piping and to take away the ballast system, for instance.
Mm-hmm. Yeah. Okay. Any questions from the audience?
Thank you. Where will the ship build that you are using in 10 years' time? Also in China or in the Baltic Sea region?
I think actually that if we manage to bring down the complexity of the vessels, then we could actually, Europe could be competitive in the future. But I think that we need to bring down the complexity and make it more easy to build than today.
Okay. Any more questions? Marcus, I know you've been thinking of something.
Thank you for your presentation. I was very astonished that everything is turned upon to get savings or better environment or cheaper or better or safer operations in this important transport sector in ship operation. I was thinking that other ship operators must have similar requirements, other ship owners and across the globe in more or less the same thinking process. And I was wondering, how do you do your developments? Do you benefit from others, or do you collaborate with other ship owners, or do you develop your own solutions and maybe sell them further on to others? Are there any? Can you see any specific way of doing business in this respect for your ship company?
Well, to start with, not every ship owner has a department like ours, and we are there to be curious and to find solutions, not too much fantasy in the solutions, but to be cost efficient. And we have a dialogue with other ship owners, but we also have a close relationship with the academia in Sweden through Lighthouse. And for instance, the autonomous ship is one example of how we cooperate with Lighthouse and Victoria Institute and so on.
Yes, any more questions from the audience? Or yeah, we have one more there, while maybe Ulf Sive gets prepared with his microphone.
Okay. Yeah, thank you for a very interesting presentation. Just a question: the presented solution for the voyage monitoring, this is on board or this is onshore solution? So you're also trying to, or you have already established such a fleet operation center, or do you heading for?
No, we as per today, we don't have a shore-based operation center. We have people on call, on duty calls all the time, but we don't have, as you have seen maybe in the commercials from Rolls-Royce and others. The system is on board mainly for the people on board, but we also take the information to do some statistics from it. We want the crew on board to be responsible for the ship and the ship operation.